Hello, today we're working on 5.4, section 5.4. We're only going to be doing half of the lesson today, but today we're going to be doing the derivative of e to the x. And at the first box on your notes, if you look up there, that's just kind of review from pre-calculus on what is e to the x and what is a logarithm. So the definition of a natural exponential function is listed up there in that first box, so be sure you take time to read that. What I'd like to do here is look at the derivative of the natural exponential function. So if I have e to the x, what is the derivative of that? Well, as you can see, it's just e to the x. Well, I'd kind of like to do a little proof so you can see that. So just basically remember the derivative of e to the x is just itself, e to the x. Here's the proof. Let's start with the natural log of e to the x, equal, which we all know is equal to x because of the log properties. So we know that that is true. What I'm going to do next is I'm going to do the derivative of both sides. The d dx of natural log of e to the x is equal to the d dx of x. So then on the right side, I know the derivative of x with respect to x is just 1. On the right side, I'm going to think about taking the derivative of the natural log using our natural log properties that we used in the previous lesson. So I would take 1 over what I'm taking the natural log of, which is e to the x, and then I'd take the derivative, d dx, of e to the x. Now what I'm going to do is I'm going to solve for that blue box. I want that blue box by itself. To get that blue box by itself, I multiply both sides of the equation by e to the x. So that cancels. So what you can see here is that my derivative, d dx of e to the x, is just going to be e to the x. All done. And then if you look on the right side of that box on your paper, we also have another derivative, more general. If I take the derivative of e to the u, it's just going to be e to the u times the derivative of u with respect to x. And that's all we're going to be doing today, is just doing a lot of problems like that. Well, let me see, not a lot. Only 9. So here we go. Example 1, I have f of x equal to e to the 1 minus x. So f prime of x, the derivative of e to the u is going to be e to the u, so you just write it down just like what you see it, times the derivative of the exponent. The derivative of that exponent just happens to be negative 1. So I just like to rewrite this because I like having the negative in front, negative e to the 1 minus x. Example 2, I have y equal to e to the negative x squared. So once again, y prime is going to be e to the u, which is just e to the negative x squared, times the derivative of the exponent, which is negative 2x. Now I'm okay with an answer like that, and I'm okay with putting the negative 2x in front. And a lot of times with e's, we just leave the negative exponents, to be very truthful, but you can also move the e to the negative x squared to the denominator. So there's my answer. Example 3. Okay, so basically we've got the idea. Now let's start adding in some of our other skills that we have. If I have y equal to x squared times e to the negative x minus e to the x, I'm going to look at that first term and realize I'm going to have to do the product rule. So here's my y prime. The derivative of the first term is 2x times the second, plus the first term times the derivative of the second. That is going to be e to the negative x times negative 1. Minus the derivative of e to the x is just e to the x. So I could leave it like that, or I can move the negative exponents to the denominator. So there we go. There's my answer. Somebody's got to show me how to shut that thing off. Please, please, please. Okay, example 4. I have f of x equal to e to the 1 over x squared, which I'm going to rewrite that as e to the x to the negative 2. which makes it a little bit easier to find the derivative. F prime of x is going to be the derivative of e to the u is e to the u times the derivative of the exponent, which is negative 2 x to negative 3. So cleaning that up a little bit, I'm just going to put the negative 2 x to the negative 3 in the front, e to the 1 over x squared as that exponent. And if we want to get rid of all negative exponents, I'm going to put that x to the third in the denominator, and there it is. Example 5 on the back page there. I have y equal to the natural log of 1 plus e to the x all over 1 minus e to the x. So to make this easier, I'm going to use my natural log properties and separate that fraction. So I have natural log of 1 plus e to the x minus the natural log of 1 minus e to the x. So now I'm going to do my derivatives. The derivative of the natural log will be 1 over my 1 plus e to the x times the derivative of e to the x, which is just e to the x, minus 1 over 1 minus e to the x times the derivative of negative e to the x, which is going to be negative e to the x. I know a lot of you would probably just write e to the x in the numerator to begin with on that first term. This would be plus e to the x over 1 minus e to the x. Now remember my rule, if you have two fractions, you have to kind of get a common denominator and add those two together. So I'm going to rewrite that as 1 plus e to the x times 1 minus e to the x as my common denominator. So this numerator is e to the x times 1 minus e to the x. Second numerator is going to be e to the x times 1 plus e to the x. If I'm going too fast, remember you can always just pause. And it might be wise just to pause at the end of the problem just to make sure everybody's caught up. Distributing that e to the x. E to the x times 1 is e to the x. E to the x times e to the x is the same as e to the x quantity squared. Now remember, when you raise a power to a power, you multiply exponents. So I can rewrite that as e to the 2x. I guess you can also think of it as multiplying like bases. You add the exponents, so that would be e to the 2x. Then I multiply e to the x times 1. Then e to the x times e to the x is going to be again e to the 2x. My denominator, when I do FOIL and multiply the first terms together, the outside and the inside is going to cancel since they're conjugates. Multiply the last terms together, I'm going to get e to the 2x. So my final answer, let's see here, that negative e to the 2x will cancel out with that positive e to the 2x. So I'm going to get a 2 e to the x all over 1 minus e to the 2x. There's my answer. Example 6. F of x is equal to e to the third ln of x. Now this is kind of a trick question. E to the third, remember, is a constant. And constants always tag along. So I get e to the third times the derivative of the natural log of x. E to the third over x is my answer. So that's just thrown in there just to kind of remind you that e is a constant. Remember, e is approximately 2.718. Keeps going. And let's move on with example 7. Use implicit differentiation to find the derivative. So here we go. E to the xy plus x squared minus y squared equal to 10. Okay, so the derivative of e to the xy, or e to the u, think about it like that, is going to be e to the xy times the derivative of x times y, which is my product rule. So that would be 1 times y plus x times dy dx. Then I have the derivative of x squared is just going to be 2x minus the derivative of y squared is going to be 2y dy dx equal to 0. Now this dy dx right here that's inside the parentheses needs to get out of that parenthesis. So basically I'm going to have to distribute this e to the xy here because I need to get that dy dx out of that parenthesis. So when I distribute that I'm going to get y e to the xy power plus x e to the xy power dy dx plus 2x minus 2y dy dx. Now if I look here, I want to keep the dy dx's on the same side. So I'm going to leave those there. Move the 2x to the other side, it becomes negative, and move the y e to the xy power. And it will become negative. Now, if I were doing this on my homework, I probably would have factored out the dy dx on that last step at the same time. So then I can see to get dy dx by itself, I'm going to divide both sides by that quantity, so I get a negative 2x minus y e raised to the xy power all over x e to the xy power minus 2y. Alrighty then. The last two, I just want to kind of go through those. Just a pre-calc review. We must be using these later on either in this section or the next section. If I have 7 equal to e to the x plus 1, do you remember how you solve for x? Maybe? How about taking the natural log of both sides? That seems to be what everybody seemed to remember the most, is just to take the natural log of both sides. So I'd get the natural log of 7, and you bring the x plus 1 down in front, times the natural log of e. And we all remember that the natural log of e right there is 1. So I get the natural log of 7 equal to x plus 1. Now the other option would be to switch it from exponential form going directly to this step, which is logarithmic form. Switching back and forth between exponential form and logarithmic form. Solving for x then, I just get the natural log of 7 minus 1. Just a little pre-calc review there. In example 9, just a little pre-calc review on that one as well. I have the natural log of 2x minus 3 equal to 5. So it's in logarithmic form. I want to switch it to exponential form. Remember, this is really a base of e for that natural log, which we usually don't write. Log base e is another way of writing natural log. So I'm going to switch it to exponential form. E to the 5th is equal to 2x minus 3. So I'd have e to the 5th plus 3 equal to 2x. Therefore, x is e to the 5th plus 3, all divided by 2. Alrighty? Okay, there it is, really quick, section 5.4, and your sub will have the rest of the information of what you need to do. Make sure you read through that first box. I think I told you that, but I'm not real sure. I didn't really address the issue of the definition of the natural exponential function. Be sure you read through that. Again, that's probably just a review of what we did in pre-calc last year. So that is it for today, and hope you have a great day. I'll see you when I get back.